Welcome back to Computer Science 4303. Today we have a bit of a chill lecture. There's not a whole lot of learning going on today. What we're going to be doing today is I'm going to be going over some more Assignment 5 and project details. And then I'm going to be showing off some of the cool Assignment 3 solutions that we had submitted for the course. So there were some bonus objectives that you could do in Assignment 3 that could get you bonus marks. And so the marker went through and pulled out, I think, the top 8 or something like that. The marker's 8 favorite bonus marks, from the submitted assignment. So I'll be going over that in just a few minutes. But first of all, I did want to go just over the D2L stuff that I had for the project and for Assignment 5. So just to let you know, the project due date is April 23rd at 11:59 p.m. So that is the last day of exams. I wanted to give you as much time as possible to work on the project. So I could have made it due before exams, but why not just make it due after exams, right? Or on the last day. So I understand that if you have a bunch of exams, you might be a bit stressed out in terms of, having to work on the project during exams rather than it being due before exams. But just treat this as if it was due before exams. If you want to hand it in before exams, you can. You can work on it sooner, right? So this is just basically extra time for you to work on your project. So by making it due at the end of exams rather than at the beginning, you basically get 2 weeks extra to hand it in if you need that, okay? So, if you have a bunch of exams, don't leave it until the last minute, is what I'm trying to say. So that's when the project is due. And if I can pull up my calendar here for a second and just double check that is the correct date. Yes, okay. So Friday, April 23rd, 11:59 p.m. So I wanted to go over the post about the Assignment 5 details as well. So I did go over some of these details in the last lecture, so I linked in the D2L post about that lecture. And so Assignment 5 has 2 parts. One part is the project proposal, and part 2 is the partial working demo. So I'll go over these details right now. So the project proposal, it was supposed to be due on Friday, but I made a typo and said March 21st, which is actually this Sunday. So congratulations, you get 2 extra days. It's now due on Sunday. But this really is not a lot of work, okay? It's just a little bit of thinking and maybe 2 or 3 minutes worth of writing and then submitting a PDF file. So it's maximum 1-page PDF format, please. No Word documents or WordPerfect or whatever. You're going to describe the main idea that you have for the project using the criteria that I talked about in the previous lecture. You're going to describe the area that you want to focus on, and you're going to list all group members' names, student IDs, and email addresses in that document, okay? So someone in the chat just said, it's difficult for me, there's so many ideas. I completely understand, and that's why this is here. So it's okay if your final project deviates slightly from this proposal. Ideally, you're not going... No, I understand kind of the catch-22 of this is that through the process of implementing the project, you're going to get new ideas. You're going to get a feel for how hard something is or for how easy something is. And so things may change, and that's fine. I just want you to actually sit down right now with your group partner and discuss the project and get a goal in mind for the project and then submit that goal. Because if your project ends up being like, oh, we're going to build a Minecraft town the size of the universe, or our goal is to build a StarCraft AI that is capable of winning the StarCraft AI competition, we want to have a look at that and make sure you're not biting off more than you can chew, okay? Similarly, if you say, we're going to make a StarCraft bot that builds 12 Marines and attacks, well, that's not enough work, okay? So we have to be able to see what the scale of your proposal is in order to give you feedback on whether or not it's enough. Someone else says, create StarCraft in Minecraft and then implement your StarCraft AI in Mine StarCraft. I agree. That would be a great project. Maybe you'd need another week or so for that, though. So here are some example project ideas. You will give me more details than this, but it's just to show you the 3 main points that I want to see, okay? So that is... Oh, and also You can no longer choose to modify UAlberta as a project. You have to code a bot from scratch using StartCraft, okay? The reason for that I posted on Discord was because if you choose to modify UAlberta, it's just deciphering the code is going to be half your project. I'd rather you get down into the nitty-gritty of programming a bot from scratch than like spending 2 weeks or 3 weeks trying to understand my code, right? So let's go with StartCraft, and you're going to write your bot from scratch using StartCraft. So if you have already started using StarterBot from UAlberta, please copy that code over to StartCraft and use the StartCraft project, because it'll be much easier for everyone in the long run and much easier for us to mark. So here's an example. Now, you're going to have to take this and expand it to be, half a page to a page long, but what our idea is we want to do a two hatchery hydralisk build. So you're going to have to build 2 hatcheries. You're going to have to build a bunch of hydralisks. You're going to be attacking the built-in AI. Our goal is to beat the built-in AI. A little typo here. So you're going to have to do things like micromanagement, scouting, build orders, all that kind of stuff is going to have to happen inside that bot. So you're going to list some of those things in the document. We will focus on unit micromanagement using Burrow or something, right? So you're going to choose a thing that you're going to focus on in order to make your AI super intelligent. Another example would be, we want to focus on making mutalisks. Our goal is to micro them well. We will focus on unit kiting, or unit micro, and implement kiting. So, you can run in and attack and then run out, and then run in and attack and run out. So that's one thing that you could focus on. Or we could make a Dark Templar rush bot. Our goal is to beat the built-in AI. Geez, how many typos did I make in this? To build the built-in AI. Geez, every single one has a typo in it. We will focus on the build order planning. So maybe you have to readjust your build order plan if you get attacked while you're building Dark Templars. Yes, so to clarify, using StarterBot, I just got a question in the chat. Using StarterBot within UAlberta is no longer allowed. You should transfer over to StartCraft that I showed you in the lectures. That should be really no amount of work whatsoever. It should just be copying the files over to StartCraft, okay? Because they both have a very similar architecture. So yeah, no longer doing anything inside UAlberta, and I will make a D2L post about that. Actually, let me make it live on stream. Why not? New announcements post. All right. Do not use UAlberta project. Yeah, someone said it was a 3 a.m. post. We can understand. I think it was actually later than that. Okay. Note, you can no longer use UAlberta as your project idea for the reasons stated in the lecture where I am typing this. All right, that's one way of saying it. Also, if you started work inside the UAlberta bot solutions starter bot project, please transfer your code to the StartCraft starter bot project. There we go. Publish. Done. That's how the sausage is made. Posting on D2L. All right. So those are some examples of StarCraft projects. And now, why is this so big? Oh, because I'm in the announcements page. How do I go back? Here we go. So those are some examples of StarCraft projects, example Minecraft projects. So in every single project, you're going to be attempting to create a village, right? That is the project. So you've got most of it done for you. You're adhering to the GDMC criteria, but I do want you to tell me what you're planning to focus on, okay? So we're going to have pathfinding. We're going to have nice paths between all the buildings so it looks like a real village. Maybe we're using minimum spanning tree or something like that. Maybe you've got a specific type of terrain integration, or you're making huge buildings which have lots of rooms and really nice interiors and bedrooms and stuff. Or you're going to be somehow using cave structures or tree houses or whatever. I want to know if you're doing anything really specific. And so what this does is it serves two purposes. The first one is that you need to start getting a focus on your project so you can do it in time. And second, we're going to review your project idea to see if it is too much or not enough work for the project. So here's how that's going to work. If you don't hear anything back in terms of feedback for your project proposal, then it's fine. You will only hear back from us if it's not fine. Okay, so if it was not enough work or too much work, that's when you will hear back. If you don't hear back, then it's fine. Okay, the second part is a partial working demo. So this is April 6th, which is almost 3 weeks from now. Okay, almost 3 weeks from now. You're going to get as much working as you can. It's difficult for me to put an actual... I can't put like a threshold of the amount of work to get full marks on this here because everyone's project is different, but I do want to see things working. So I should be able to look at what is working, look at your code and say, okay, they have made progress toward their goal, like significant progress, okay? So if you're making a StarCraft bot, you should have units building, you should have units attacking, but maybe you're not like done fine-tuning everything. So this is like an important deadline that you have to meet in which you have actually done a significant amount of work toward the project. You must submit the working code so that we can run it to test what you have working, and you must submit a text file specifying what you have working so far so we can look at it within that context, all right? Because if I just run your bot and see stuff happening, it's difficult for me to know what you've actually done. And please keep in mind that this is not just like extra busy work. Literally everything that you're submitting for assignment 5 is going to be part of the final project. So even though it's called assignment 5, maybe I should have called it something different, right? Maybe I should have called it a project milestone or whatever. But that's what it is. It's a project milestone. It's just to keep you on track with the project so that you aren't doing everything in the last week. And like with my 4,300 projects last term, I had people 5 days before the project was due asking me about setting up Visual Studio. I don't know how they got through the course to that point, but they did, so props to them. But 5 days before the project was due, there was a problem with setting up Visual Studio. So they obviously didn't work on the assignments anyway. That's a whole other thing. So yeah, that's just I wanted to read over that and clarify things. And it's due on Sunday now, not on Friday. So let's, for the remainder of the lecture, go over some of the cool assignment 3 solutions. So let's minimize this. And I'm just going over them in alphabetical order. Okay, there is no rhyme or reason to this. It's just alphabetical order, and I was given 8 assignments to look at by the marker. So the marker said that these were the 8 that got the most bonus points. So let's just have a look at them. So the first one was Andrew Nash and Mark Duffett. Someone is asking what is due on Sunday. Just go read. I just said that. I don't know how you can ask that. Like, it's right here. Just go read it. Come on. I don't get that. Anyway, not trying to make fun of anyone, but that's a ridiculous question because I literally just said that. Anyway, please go read the D2L post. And like I had someone in the project. I had someone in the class this term. I think I may have explained this already. Said that them and their partner, so these 2 people who were working together, and I'm not going to name names, took turns watching the lecture. So like, they had a question. I said, I went over that in detail in the lecture. Did you not watch the lecture? And they said, I watch the even lectures and my partner watches the odd lectures. Can you imagine that? Like, if you get away with that, props to you. But why would you tell the professor that? Why? Why would you tell me that? Oh, man. Just some of the stories behind the scenes is just... Anyway. That's called, I need an exam in this course. Jack. I wish I could smack a student through Twitch. Am I going to review the project? Yeah. The real move is you and your partner alternating courses. There you go. Yeah, doing each other's assignments for them. All right. So the first one is Andrew Nash and Mark Duffett. For the record, the person I wanted to smack is laughing in the chat. So it's not student abuse. All right. So here is the explanation. Oh my dear Lord. So I actually have not looked at these yet. So I wanted my reaction to be the same as yours. So this is Andrew Nash and Mark Duffett. And here is the bonus features explanation. So Perlin noise, semi-realistic planet terrain generation. Closest planet to the star has hot lava terrain. Oh, that's cool. Furthest planet from the star has cold ice terrain. Middle planet always has Earth-like terrain. Earth-like planet also uses an additional Perlin noise matrix to determine biomes. 4 different biomes. Generic grass and mountains, deserts, rainforests, temperate forests. All other planets have terrain, have terrain a combination of terrain colors based on planet color. Sometimes this leads to very plain/flat planets. We consider this a feature, not a bug, as you would, right? All right, so let's have a look. Let's launch this. Okay, so here is the universe. We've got lots of stars. That's cool. I mean, that all works. Perfect. So we've got some really tiny stars. We've got some bigger stars. Let's just click on a random one. And now they said that planets... Let me click on one that has a bunch of planets. Here we go. So they said that planets closer to the stars are lava-like. So let's click on one of those. Oh, cool. So here we go. We got some nice Perlin noise. Oh, it's a little laggy. But that's okay. That's okay. So we're zooming in. And so we've got the Perlin noise. That's really cool. So it's fire colored. Because this is like the Mercury of this planet system. Right? That's really cool. I really like that. And let's make sure that if we regenerate it, it's the same planet. So let's look at this middle structure here. And we'll go back in. Indeed it is. Okay, so they said the furthest planet away from the star is an ice-based system. So let's click on that. And indeed it is. Well, they are true to their word. That's really cool. Those colors look great. I like these colors actually even more than the other system. But why is all the water blue? Shouldn't the water be frozen? Sorry. I'm not criticizing it. I gotta sneeze. This project is so good, I have to pick out faults with it, right? Everyone who I'm showing off, apparently the marker said they all got 100. So the frozen water is the white ice. That's true. That's true. So yeah, this is really cool. I like it a lot. Now let's go to a middle planet. So here we are in a middle planet, and we've got some cool stuff happening here. So we've got sand, we've got water, we've got fire. I don't know. Is that sand? Desert. Okay, it's desert. Okay. That's cool. No, that's really neat. I'm going to go to a couple more planets. Oh, no. Okay. So the planets have biomes. This is the desert, it looks like. Cool. Uh-oh. Is this the feature planet? Is this the feature planet? Someone asked, is there anything hidden behind your cam? Do you mean behind me or behind the webcam? Behind my webcam is the wall. Behind me is a shelf. Okay, here we go. This is a little better. Oh, I see. Sorry. You're right. Let me move this down. Perfect. Okay. Yeah, so you're right. This group actually lists the frequency redistribution octave. So these are the Perlin noise variables. So that's really cool. Let me look at one more star system that has a bunch of planets in it. Here, star system. Okay, not a lot here. I want one. Here we go. Okay, this one has a bunch. So again, lava-like planet up close to the star. That's awesome. And ice-like planet far away from the star. That's really cool. Love it. Middle planets, we've got some grass. We've got like a normal Earth-like terrain. We've got a green one. No, this is cool. I like that one. So great job to Andrew Nash and Mark Duffett for that assignment. That was really cool. All right, next we have Brianna McDonald and Kyle Codner. Oh yeah, I didn't look at the planet names. Planet names. Okay. So this is a Smaug. So these are the star names: Smaug Pi 37, Zazima Chi 35. Okay, so these are like sci-fi / anime. I know who Frieza is. I know who Venom is. I know Majora. I know. Okay, yeah. So these are all like video game / sci-fi / anime characters for the star names. And then if we go into the planets, Dogecoin to the Moon 48. Okay. Good job. Bitcoin Xi OOF. I like it. RS Gold Ho. Any GME planets? Any Diamond Hands planets? Terra FE. Binance Coin. Is there any BitConnect? Terra. Bitcoin Cash. Cool. No, great job. I like that. Okay. So next, Brianna McDonald, Kyle Codner. Let's read the bonus features. For bonus marks, we generated the terrain using Perlin noise, created a twinkling effect for the stars, and added a lifespan to each star based on its temperature. Interesting. The twinkling works by changing each star color to a slightly lighter color for 60 out of the 200 iterations. Oh, neat. Of the generate star function. So let's say it again. The twinkling works by changing each star color to a lightly color for 60 out of each two. Oh, I see. Additionally, we added several extra colors to the terrain. Okay, so if either Brianna or Kyle is out there, how does the lifespan work? Are stars going to start disappearing on me? Oh, that's cool. You can see the twinkling effect in the stars. I like how it goes from left to right, like it sweeps. That's pretty neat. I want to see, does the lifespan? Oh, I see. Okay, so it's not an actual lifespan where they'll disappear, but you've added like actual text here. So let's see. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this star will live for 11 billion years. That's cool. That's neat. I like that. So let's see what the star names are. We got Solaris, Kepler, Centauri, Cygnus. Okay, so you actually went and got some like real star names. That's cool. I like that. Okay, let's look at some planets. Let's get a star system with a bunch of planets. So we're going to look at a random planet. Let's look at this one. And we've got some Perlin noise. Cool. I see Kyle is out there in the chat. Can you explain these structures? Is this supposed to mean something? Did I miss something in the... Oh, Endor 1. I like that. The planet is named after a Star Wars planet. Tatooine 3. I like the color scheme too. This is a sort of a mini planet in here. Is this like gold deposits? Silver and gold deposits. Nice. I like it. I didn't see that in the text file. Sorry. Cool. Oh, this is a really neat one. Oh, we've got some gold over here. Awesome. Let's look at one more system. This one here, we've got a really big planet. The color schemes are cool. How did you decide on the color schemes? Ooh, I barely saw this in the back here. It's actually way easier to see on OBS than it is on in the game. So that's really great. Good job on that. I really enjoyed it. Okay, next is Christopher Yates and James Hudson of Tron fame. Bonus features. Oh dear. We got a lot of stuff here. If you click on the map of a planet, you get a character that you can control on the planet. Okay. WASD to move, click to shoot. I assume that means click mouse button. The character cannot walk on water or swim, so no moving on blue squares. The player also cannot walk on the map. The player moves slower the higher the elevation of the square he walks on. There are enemies on most of the planets. The number of enemies is determined by the temperature of the star that the planet orbits and the size of the planet. Okay. The enemies will constantly fly toward the player, can move over water. Enemies can overlap, simulating them flying while stacked on top of each other in the y-axis. The enemies cast a shadow that gets close to them the higher the elevation of the square that they are flying over. Oh my dear. I'm going to give you bonus marks just for writing this text file. If an enemy touches the player dies and is sent back to the map screen. The enemies have 5 health, and sometimes shot can miss to simulate the player missing on the y-axis. Definitely not just bad hit detection. I like that. That's great. Each planet has the status of unknown until a player lands on it, hostile while there are known to be enemies on it, and safe when all known enemies are dead. So you actually made... so the status is reset whenever the player leaves the planet map view. So you made No Man's Sky. Nice. Nice, nice, nice. Okay, so let's go in. Let's see this. Okay, so we've got sort of the default star view here. Let's see the star names. Vikeji, Ludaha, Kahifo, Dumija. Oh, I bet you alternated vowels and consonants, hey? Is that how you made your names? Yeah, cool. That's a cool way to make names, actually. I like that. All right, let's click on a star. Let's get one with a bunch of planets. All right, so we've got a bunch of planets. Let's go to the first planet. Here we go. Here is the planet. So I'm going to click on it. Oh no, I'm stuck. What did you do? How rare is that? Okay, so I have to click on the planet. Oh, that's where I land on the planet. Gotcha. Oh, this is cool. This is cool. Ah! Oh, that shadow is nice. That's a really nice effect. You can see it changing with the terrain. That's really neat. I like this. When is this going to be on Steam? That's great. Status, safe. So it went from another status. So if I go back into the planet, status is unknown. Status is hostile. Yeah, cool. That's really cool. Really well done. Let's go to a new one. Status unknown. I'm going to click in here. Status is hostile. And I can't zoom. So I can no longer zoom at this level. So they made it like actually you have to kind of explore it. You can't... No, that is so cool. That's really well done. I assume you spent a lot of time on that. That's really crazy. Excellent. Excellent job. That's just awesome. Let's see. I want a bigger planet. Okay, this is hostile. I'm going to go on top of the peak. So I'm moving kind of slowly up here because it's higher, and then I move Yeah, I do move faster as I go down towards sea level. I cannot go into the water. I'm going to see how many enemies I can collect without dying. Oh dear. You implemented steering as well? Look at that. Steering behavior implemented. Nicely done. Can't go on the water. They can fly over the water. That's so cool. Great job. I would keep playing it. It's actually really fun to play. That's cool. All right. Moving on. Excellent job. Daniel Power and Liam Waghorn. Bonus features. Many different types of biome. Biome is shown on each planet. Oh, that's cool. I like how people went the biome route. So let's look at the names. We've got Tabit 700, Fafnir 305, Sheliak 6, Fafnir. Okay, so you've got some hard-coded starting names. I don't know the reference for these names. Can someone? Canopus, Murga, Hasela, Mirak. Are these like characters from something? They have sort of a Middle Eastern flavor to them. Okay, not that one. Never mind. Caus Australis, Electra, Answer. Are these I don't know what these are. Are they just something you made up, or are they actual like fictional characters or something? Okay, let's click on a star system that has a bunch of planets. Here we go. So this is a smaller planet. I want a star system that has bigger planets. Here we go. This one has bigger planets. Ooh, this one is complex. So the biome is Earth. So we've got some Earth colors. We've got water. We've got grass. We've got some rocks. That's really cool. We've got some sand. Another one. Biome is Aurora. Oh, yeah. So the colors look like an Aurora. Northern Lights. That's really cool. Here we've got biome of Jupiter. Oh, cool. So it's kind of like the gas cloud. Yeah, these colors are really cool. I like that. Biome Mars. Oh, that's neat. It actually like looks like the things that you're describing. So well done on the color schemes. That's really awesome. I like how this one looks like a Space Invader. Cool. Let's look at another planet system. We've got Mars again, a big old mountain. Desert, small desert planet. Another Mars planet. And the colors reflect the colors. Oh, that's cool. Yeah, I really like that. Great job. The color schemes were really great. And it actually, like, the features made it look like you were actually at the features. Like, Earth was very densely changing, but Jupiter, like the gas giant, had very sparse features, which was nice. Great job, Daniel and Liam. All right. Next, we have Jack and Jared. So, bonus features. Oh, jeez. Okay. Perlin noise was used to calculate the terrain of each planet. The number of octaves and persistence used in Perlin noise computation was also randomized via the seed for each planet. Different planets have different habitats and life forms. Cool. Uninhabitable planets have a rover with a nod to 3200. We have a rover. Was there a rover in 3200? Am I missing something there? We have 5 types of planets. Nova Terra, Earth-like, fan base, toxic water, tundra, frozen, Gerudo, desert, Heatran, lava. Each of these have different color palettes. All different types of planets can appear orbiting any star, but different star temperatures will make different planet types more common. For example, stars with a temperature above 20,000 are more likely to spawn Heatran-class planets. Oh, cool. There are 3 types of life forms: mammals, marine life, and birds. Each planet has a generated sea level and tree line. Birds spawn above tree lines and can move anywhere. Mammals spawn between the two and remain there. Marine life spawns below sea level and remains there. So that's cool. Someone in the chat asks if this is what you're about to make. No, we're showing off assignments that students have made. The rover will either move up to its highest or lowest elevated neighbor each frame while collecting samples. Okay. The rover will not enter below sea level. So I can't control the rover, right? It's automated. The rover's battery drops each frame. When it reaches 0, it will begin to solo charge. Oh man, wouldn't it be cool if we used the temperature of the planet's sun to calculate how fast it charges? Oh well, it's 9 p.m. Thursday, too late to add more. Oh, that's great. Each rover has a unique alphanumeric code and named after 3200. Oh, I see. We did use rand instead of seeds for life form movement. I see. So that it would move randomly every time you generate a planet. Okay. That is really freaking cool. Let's see if it works. Because that's a lot of stuff. All right. So let's look at the star names first. We've got Ansible, Kongu, Bonveri, Cadmium, Agni, Sensi, Collapsium, Irinidu Sensi, Gazebo, Congo, Cutco. So are these like random words? How did you come up with the set of words here? I saw Dalek, something sci-fi related. Yeah, there's a Dalek. Cool. So let's click on a planet, and now we'll see. Let's click on this big one. Oh, nice. So it looks like we've got birds. Are these, so these are the birds up here, these teal ones, I guess. And we've got mammals. So the brown ones are the mammals. Where is the rover? Where's the rover? What area am I supposed to be looking for the rover? What color is the rover? Rovers are only on lava or toxic plant. Oh, I see. Okay. Cool. No, this is neat. So the birds are flying over. Let's get rid of the grid. The mammals are sticking to their part. This looks like a bunny. Does anyone else see that? Please tell me you see the bunny. That's hilarious. Well, I see a bunny. Here's the eye, here's the mouth, and here's the ears. Or a bat, yeah. That's great. Okay, let's go to another planet. This is a... Oh, cool. Rover coordinates. We've got rover. Oh, here's the rover. Look at this. All right, so here's the rover moving around doing its thing. It's moving up. Oh, we got stuck in a local optima. Oh, no, we didn't. Did we? Are we stuck in a local optima, Jack? Well, I guess you're always going to get stuck in some sort of optima, right? So its battery is going down. Okay, it goes between moving up and moving down. Cool. Okay, rover name. No opportunity. Ah. Nice. Nice. Your camera is... Oh, sorry. There we go. There's the battery going down. I'm waiting until the battery depletes so we can see what happens. You've collected 17 samples so far. No opportunity. Oh, God, I'm not getting into that. Oh, no opportunity or perseverance. That's really good. Really good. Let's get that battery down to 0. And then we'll show some other planets. Okay, battery, 2%, 1%. Charging. Okay, and it stopped while it's charging. Nice. How long does it take to charge? Like a minute? Okay, well, we'll assume it works. I'd rather go look at other stuff. Here we go, another planet with another rover. Cool. Yeah, I like this. I want to get to another habitable planet, so let's go see. Did I really just click on the same one? Okay. Unless the bunny is everywhere. Oh, here's another type of planet. This is a habitable planet. We've got, okay, so this looks like aquatic life. So this is a sea area, and then we've got more mammals. No birds on this level. Pinks are fish, yep. Looks like they're under ice or something. Maybe I'm mistaken. Here we've got another habitable planet. This is a Gerudo class planet. So Gerudo, because of Ocarina of Time, desert area. I like it. You're playing to my likes. Oh. So what type of... I guess this is some sort of... some sort of waterbed down here. If it's got fish in it. Frogs. Oh, okay, frogs. Cool. Let's go to yellow. Here's another one with the rover. Ooh, this is cool. This is a Nova Terra type planet. Nice. Have I missed any types of planets? What is the brown one? No, that's Gerudo. This is fan base. Is there another type? Oh, I want to go to this one. Here we go. Cool. No, that's really neat. I like the amount of effort that people put into these assignments was great, and bonus marks definitely deserved. Great job. I really like it. We'll go to this really tiny planet before we close it. Only 4 people on that planet. Cool. Thank you, Jack and Jared, for that one. Okay. So we've got Keegan, I guess, worked solo on this one. Bonus features. Excuse me. Perlin Noise implemented multiple color planets, 5 colors. Planets have types so that their outer appearance will likely match their inner appearance. So blue planets biased toward water, green planets biased towards grass, etc. Oh, that's cool. So let's have a look. So we've got lots of stars in this one. Pale blue giant, 115. Golden giant, 495. Golden giant, 980. Red star, blue star. Oh, that's cool. So you've like taken the temperature and the color and sort of named the planet after the color. That's pretty cool. So let's have a look here. Okay, well, we've got a green planet. This is a grass planet. Successful eye done, 165. Nice. We're going to another one. So these are obviously like the Earth-like planet terrain. I like how the features are... Actually, this one looks like a face with like 2 eyes, a nose, and a mouth. Blue. Okay, I see. So there's more blue on the blue planets, and there's more green on the green planets. Cool. So this one is a bit of a rocky planet. So you've chosen the Perlin Noise features that don't, like, you're either zoomed in a bit or you prefer the Perlin Noise features that create more smooth like planet surfaces rather than really like intricate details. Persistence is probably low. Yeah, so you could tweak that to be different if you wanted it to. Cool. There's nothing good or bad about that. It's just preference. So someone said it doesn't look as random as the rest. It looks pretty random to me. However, the size of the features is just different. That's all. So yeah, a couple of assignments put in like bonus things like animals or whatever, but that was not part of the project. These are the bonus features that people have chosen to implement. So that's really cool. I like that one as well. Thank you, Keegan, for implementing that one, and impressive to do that on your own. Here we have Nishant and Ronak. So let's look at the bonus features. So each planet's terrain has water. The water's color is dependent on the local time of the planet. During the day, a planet's water is drawn using a dark blue color, but at night it is icy white. You can see the local time on the planet's scene. Oh, that's cool. So you use time of day. Let's see the, we've got senators, maple leafs, thingamajig, Skywalker, maple leafs. Okay, so you've got Roman numerals and a bunch of random words like sports teams and sci-fi stuff. Okay, so let's click on a planet and we'll see it looks like all of the planets have the same color in the star view. So let's just visit one. Okay, so we've got local time 11:25 p.m. And as stated, the water is drawn an icier color at night. So that's cool. What are these red things? Is anyone from this group in the chat could tell me what these red things are? Are these like I don't know. It wasn't mentioned in the thing. So it's 3:18 a.m. on this planet, and so it's still at night. So it's still a lightly colored sea. This one is 5 p.m. So okay, so now we've got a more dark blue color for the water. Oh, that's cool. This one is 10:29 a.m. I think that should maybe be blue, but we'll see. Another one. Let's try and find another one in the middle of the day. like in the afternoon. Okay, so this one's 9:30 a.m. and we've got a more dark blue color. That's cool. Press P for Merlin. What? P for Perlin, you mean? Oh, wow. Okay. That should be the default. This is really cool. So let's go to a bigger planet then. So here's a bigger planet, and we press P. Oh, okay. That should have been there. That should be the default. That's cool. I like that. So this is 11:39 a.m. So we've got a dark blue color. Let's go to a planet that's at night. So this is still in the day. Still in the day. 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 Let's go to a planet at night. 1 a.m. Yeah, press P, entire assignment shows up. So I guess Perlin noise is not affected by the time of day, just this default view. I think that's what's happening. But still, no, that's cool. Good job with the Perlin noise. It's completely different than the other one, but that's fine. That's just two different ways of implementing it. So that is completely sufficient to get the bonus marks. And I really like how you implemented that. Great job. Okay. And the last one is Zaheen and Samanto. So let's see. Utilized Perlin noise in CA generation. Okay. Huge detailed maps for some planets. Let's see what this looks like. So we've got a planet here. We're going to look at it. Oh, wow. You weren't joking about that. Okay. So this is a huge planet with lots of details. And you used Perlin noise in the CA generation. That's cool. So did you, or if you're out there, did you apply Perlin noise and then after Perlin noise you applied the CA? Or how exactly did that work? Yeah, these planets are quite big. Oh my. This is going to be a PowerPoint show. Oh dear. Look at the size of this thing. This is a large planet. I have a fast computer. Good work. I like the colorings. They're very natural looking. This is going to be a large planet. Oh my. Yeah. Really well done. I like it a lot. That's really cool. This looks like a map of Europe almost. Yeah, I don't know. I wish they were here and can give us the details about how exactly it was done. That's all I have to go by right now is the... Oh, that one looks... This one looks really nice. This could be like an aerial photo. Really well done. That's really cool. So I really like that some people went for like super detailed, highly realistic. Some people went for like arcade mode. Some people put in animals. Some people put in time of day. Some people put in biomes. Like just really, really cool. Great job. And if yours isn't here, it doesn't mean you didn't get bonus marks. It doesn't mean you didn't do a great job. I didn't have time to look through all of them myself. And so I asked a marker to send me 8 of them. And so these are the 8 that were sent to me. So for the people who did these, thank you so much. It's really, really cool. And I'm really happy to be able to show it off. Have you seen anyone make black holes in previous years? No. So no one really modified the star system. So other than Brianna and Kyle, who'd made them twinkle, I don't think anyone has actually modified the stars like that to make them move or anything. It's kind of hard to do that though because of the way that the RNG works in the assignment. So that's not saying anything bad about the students. That's more so saying that like my assignment didn't put in a lot of room. Oops, I wanted the just chatting. Where's the just chatting scene? Let me okay. Oh, jeez, let me go back off of that, my ugly mug. All right. So I'm going to stop the recording now for YouTube, and I will see you back here on Tuesday.